Alright, geometry. Today we're going to do an extension on something that is really important with trig, and that is the laws of sines and cosines. And these you use with oblique triangles. So an oblique triangle, usually your scalene triangles. They just call them oblique for a fancier name. So the first one I'm going to go over is the law of sines. You cannot do the Pythagorean theorem with oblique triangles because the only time you can do the Pythagorean theorem is if you have right triangles. Okay, so no Pythagorean theorem. Regular SOHCAHTOA will not work on oblique triangles. That's why we have to use the law of sines or the law of cosines. So law of sines first. Sine big A over little a equals sine big B over little b, which equals sine big C over little c. So when I'm saying big A, big B, big C, those are your angles. Little a, little b, little c are the sides. Okay, so, and remember back to when we were doing the triangles and trying to locate which side was greater and which side was less than, we would do, across from the angles. So, across from your bigs, and a lot of your triangles that you will have in your homework are not labeled. So go ahead and label them how I did. Just do ABC clockwise around the triangle. Okay, so across from the bigs. So across from big A, here would be my little a. Across from my B would be my little b. And across from this big C is the little c. Okay? So when we are looking at these, make sure that you are labeling them correctly, just so I can see how they're labeled on your homework. So the first thing is really easy, and that's my big A, because we're finding all of the missing measures. I need big A, little b. So my big A, that's easy. You take your 180 minus the sum of 56 plus 47. That will give you your big A. Or 56, that's plus 47 is what I meant. So you should end up getting 77. So our big A is 77 degrees. Okay, so now all of these proportions are set equal to each other. So when you're setting up proportions, it's pretty simple. Okay, so I can go ahead and just set up my proportions. I know my big C and my little c, so I'm going to use that one. My sine big C over little c equals, let's find little a. My sine big A, which we just said was 77, over little a. When two proportions are set equal to each other, cross multiply to solve. A sine 56 equals 16 sine 77. Well, how do you get little a by itself? Just divide by sine 56. Okay, so in your calculator, you would type in, make sure your calculator is in degree mode. That's the key. So I would type in parentheses, 16 sine 77, parenthesis, divided by sine 56. Close the parentheses. You should end up getting 18.8. So little a is 18.8. So we found big A, we found little a. So now we need to find big or little b. So I'm going to go ahead and use C again because all of these proportions are set equal to each other. So I would say, again, use my sine 56 over 16 equals sine big B, which is 47, over little b. Cross multiply to solve. So I'd have B sine 56 equals 16 sine 47. Divide by sine 56. So same thing. We're just going to type back into the calculator. And you should end up getting little b is 14.1. So there's your A, little b. So there is the law of sines. Okay, again, go around the shape, find your, label it, and I just did clockwise, ABC. And then if you need to, label your littles, okay? Do your littles right across from it. And then plug in. And again, all of these proportions are equal. Okay, so notice I kept using C over and over again. I can do that because they're all equal to each other. And then make sure you're cross multiplying. So law of sines isn't too bad. Not very hard. It's just plugging in and then just solving from there. Okay, so here comes law of cosines. Okay, law of cosines. A squared equals b squared plus c squared minus 2bc cosine big A. There's one equation. B squared equals a squared plus c squared minus 2ac cosine big B. There's another equation. C squared equals a squared plus b squared minus 2ab cosine big C. Okay, now one thing I do notice about this, with the law of cosines, Pythagorean theorem's in there. Okay, a little bit. With it, and then you have the ratio of the sides, and then your angles. Okay, so if they give you a triangle, label. Okay, A, B, C. Okay, just go ahead and label right across. So it doesn't matter which one you start with, because every single one we're looking for our bigs. Okay, so it doesn't matter which one we start with. I'm going to start with, let's just start with an A. And again, if you have to, label it. Little a, across from this, little b, across from that, little c. So let's plug into this one right here. So we would have a squared equals b squared plus c squared minus 2b c cosine big A. Okay, and I ran out of room there, so this is over here. Now, solve these out step by step. Okay, do your order of operations. So 11 squared, 121, equals 36 plus 49 minus 2 times 42, because 7 times 8, so it'll be minus 84 cosine big A. Okay, I'm going to add those two. 36 plus 49. I get 85. So I get 121 equals 85 minus 84 cosine big A. Now here's the thing. You can't add or subtract those two. Okay, because this is a coefficient of that. Therefore, I have to take my 85 over here. So I'm going to subtract my 85 from my 121. So 121 minus 85 gives me 36. So I have 36 equals my negative 84 cosine big A. Notice I'm keeping the negative with it because that is negative. One more step to get my big A. We're finding an angle, right? So when you're finding an angle, we're doing the inverse function. So it'd be cosine inverse, and you know you had to divide that over 36 over negative 84. Okay, so second cosine to get that cosine inverse. 36 over 84, and make sure you get that negative in there. So I get 115.4 degrees. That is my big A. Okay, 115.4 degrees is my big A. So we got to do it again. Let's do it with little b. So we're going to have little b squared. So 36 squared, or 36. I'm going to write it out. So 6 squared equals a squared plus c squared minus 2ac cosine big B. And again, same thing. We're going to solve it out step by step. So we're going to have 36 equals 121 plus 49 minus 154 cosine big B. Okay. Add those two. 121 plus 49 gives me 170. So this would be 36 equals 170 minus 154 cosine big B. And then subtract your 170 over. You get a negative 134 equals negative 154 cosine big B. And then one simple cosine inverse of this, negative 134 over negative 154. And you can go ahead and just do it as a positive because two negatives are a positive. So I end up getting 29.5 degrees. Now, how easy is it to find big C? Do I have to run another one? No. To find your big C, all I would do, let me use a different color so that we can keep things separated here. To find your big C, do what you always do because they have to equal 180. So C would equal 180 minus the sum of 115.4 plus 29.5. So 180 minus 115.4 plus 29.5 gives me 35.1. Big C equals 35.1. So now I've got my big B, my big C, and my big A. And that's how you do law of cosines to find those angles. Okay, I'm going to do one example where we are finding, for the law of cosines, where we are finding a side length. Okay, because again, I can't use law of sines because I don't have two angles in there. Okay, I have one angle and I don't have the correct proportions to set up. So I'm going to go ahead and use law of cosines. Again, I'm going to label it just like I normally have, A, B, C. Okay, so label your little sides. Little c, little a, little b. I can go ahead and now find little c. Okay, I can find my little c. Because I have little a, I have little b, and I have big C. So if I look at my C, I've got my little b, little a, big C. So we're going to have c squared equals a squared plus b squared minus 2ab cosine big C. Okay, step by step. 81 plus 196 minus 252 cosine 36. 81 plus 196 is 277 minus 252 cosine 36. Okay. So 277, and I'm going to go ahead and type this in straight across. I'm going to put parentheses around like this. So I'm going to do 277 minus parentheses 252 cosine 36 parenthesis parenthesis. I get c squared equals 73.13. How do I get rid of that squared? Root it. So I'm just going to go second square root of that answer, and I get 8.6. So little c equals 8.6. So that is 8.6. And the rest of it, you do exactly like we did the problems on the previous one. Okay, where you're going around and you're trying to find the angles. So I just wanted to show you both ways. Okay, you'll have to find one more angle on that one to complete the example. So there is law of sines, law of cosines. If you need more examples, please let me know, and I can get more examples on there. There are some great other videos out there that do the law of sines and law of cosines as well. So there it is. I hope you guys all had a great Easter, and we'll talk with you in a Zoom meeting.